Hi there, so this is the chapter, or should I say part 2 of my review of chapter 18 of properties of determinant. So we have discussed the first three, so these are okay, these are okay, and these are okay. And I just want to state that they are the basic one. So what does that mean? That the rest of the properties, so from 4 to 10, when I discuss them, I might refer back to the first three because they are sort of the building blocks of the other properties. So let's continue on with property number 4. So two rows equal and the determinant of A is 0. So let's bring back our matrix A here. So I'm interested in knowing the determinant of this matrix. So these two rows are equal. So let's say I just change the column, but the number are the same. So the first determinant is let's say some number x. Although it's really clear that if we use this formula right here, so AB minus AB will be 0, but let's say we still don't know if this formula is correct or not. So let's just assume that the determinant A now is some number x, okay? And let's use property 2. Let's say I exchange those rows. So the green one now, the second row moves to the first and the first moves to the second row, but in the end they still contain the AB, so it is still the matrix of A. But based on the property number 2, the determinant should be minus x. So when is this case is possible? The only case when this one is possible is when the x is 0th. So the determinant of a matrix with 2 equal rows is 0. Okay, so that's number 4. So the fifth is subtracting one multiple of row from another, determinant remains unchanged. So this refer back to the elimination that we did in the previous lesson. So let's bring back the matrix A here. So let's say I have this matrix A, B, C, L, A, D minus L, B, which is just some multiplication of a factor L of the first row. And based on the property number 3A, number 3B, I can separate them, I can factor them out into this form, right? And then, so the first row remain unchanged, and then I have this in the second row now. And then if I go further, I use the property number 3b now. Let's see how I refer back to the property number 3. I can get this. And now I can use property number 4 to say that this is 0. Thus, this still the A, and the determinant of A is still the same as the original one. Determinant of A. Okay, so that elimination doesn't affect the determinant of A, our original matrix. And then regarding property number 6, I just want to briefly discuss it here. So let me free some spaces quickly. Okay, so basically number 6 talks about the matrix being dependent. So when you do some elimination, if you remember from previous lessons, then you end up with some 0 rows of 0 here, then you know immediately that this matrix is dependent, has dependent rows in this case, and it is singular and it is non-invertible, so the determinant is A. Actually, that's just really a simple way to remember. So we know whenever we see a row of 0, then we know immediately that it is non-invertible, they are singular, so the determinant of A. Some proof that you can use is if you try to do some elimination, if you add the row of 1 to the row to the second row, so you will end up with AB, and then you know this one plus 0 plus A, 0 plus B, so you end up with the two rows of being equal, so we can use the property number 4, and this will say that the determinant of A is 0. So it is some proof that maybe we can use, but always remember it is really easy. The row of zeros determinant will be 0. And I'm not only mean the second row, so you can always have, of course, like 0, 0 CP. This will be also be 0. So that's it.